Hello everyone, welcome back to my channel once again. So today we are going to start fourth chapter, acids, bases and salts. So we use in our daily life a large number of substances such as lemon, tamarind, common salt, sugar, vinegar. So, do they have the same taste? No. Okay. So, lemon has sour taste. Even tamarind is also having sour taste. Common salt, it is again the difference is salty taste. Sugar has sweet taste, and vinegar has again sour taste. So, they have a different taste. So, let us recall taste of all these edible substances listed table 4.1. Okay, so you can write down this. So what you will see, what you will observe that if you have not tested any of these substances, test is now and enter the result in table number 4.1. So you will find out some of these substances taste sour or sour, you can say. Then some taste bitter, then some taste sweet, and some taste salty. So, what are these? So, in this lesson, we are going to understand about acids and bases first of all. So, the curd, lemon juice, orange juice, and vinegar taste sours. Okay, so these substances taste sour because of they contain acids. Okay, they contain acid. It is a substance which gives the sour taste. The chemical nature of substances is acidic in nature. So the word acid comes from Latin word that is acer, which means sour. The acids in these substances are natural acids. Okay, these are the natural one, they are not having the chemical. So what about baking soda? Okay, we are using for making so many dishes. So does it also taste sour? If not, what is its taste? Okay, so since it does not taste sour, it means that it does not have the acids. It is bitter in taste. Okay, so if you rub its solution between fingers, it feels soapy, right? So generally substances like these which are bitter in taste and feel soapy are touching are known as bases. Okay, so the nature of these substances is said to be basic. So here what we are going to understand about the acids and bases, there is a difference where acid is having the sour taste and the base is having not only the sour taste, it can be bitter in taste. So if you cannot taste every substance, yes, but how do we find out the nature of it? So special type of substances are used to taste whether a substance is acidic or basic. There is an indicator. Okay, so there is an indicator that the substance which shows the substance is acidic or basic. So such substances are called to be indicators. So the indicators change their color when added to a solution containing acid or basic. Okay, so basic substances. So some are in nature, some are the natural indicators. In that, turmeric, litmus, china rose, petals, or gudhal, etc. are some of these naturally occurring indicators are there. So how we can get these naturally occurring indicators? So before that, let's understand the name of the acid and in which they are found in. So acidic acid, which found in vinegar, formic acid, and citric acid or citric acid, citrus fruits such as oranges, lemons, etc., lactic acid, curd, oxalic acid, spinach, ascorbic acid or vitamin C, which present in amla citrus fruits, tartaric acid, tamarind, grapes, unripe mangoes, and all the above mentioned above are in nature. They occur in nature. Okay. So now name of the base and which found in calcium hydroxide, which found in lime water, ammonium hydroxide, window cleaner, sodium hydroxide or potassium hydroxide, that is a soap, then magnesium hydroxide, that is milk of magnesia. So these are that this is for your extra knowledge. Okay, and yes, and this table will come in UPSC exams. Now litmus, a natural dye. How we are getting this litmus? So the most commonly used natural indicator is litmus. It is extracted from lichens. Observe this picture. Okay, this is a lichen. So it has a maw that is purple in color in distilled water. When added to an acidic solution, it turns red. Okay, when this litmus, when you add it in acidic solution, it turns into red color, and when it is added to the basic solution, it turns into blue color. So in acid, Remember that is turns into red, and in base it turns into blue color. So it is available in the form of solution or in the form of strips of papers, and generally known as litmus paper. Okay, generally it is available as red and blue litmus paper. Here is a picture. This is a red one and this is a blue one. Okay, so in acid it shows the red color, and in base it shows the blue color. Now we have one activity here. Mix some water with lemon juice in a plastic cup or tumbler or test tube. Put a drop of above solution on a strip of the red litmus paper with the help of dropper. Is there any change of color? Repeat the same exercise with the blue litmus paper also. So note down the change of the colors. Okay. So now perform the same activity with the following substances also. So here they have given some other substances: tap water, detergent solution, aerated drink, soap solution, shampoo, common salt solution, sugar solution, vinegar, baking soda solution, milk of magnesia, washing soda solution, lime water if possible, if make solutions in distilled water. Okay, so tap water is not a distilled water, you have to remember that. Now record all the observation as in table number 4.2. So in your table, are there any substances on which litmus had no effect? Yes. So yes, of course. So the solution which do not change the color of either red or blue. Yes, it is a certainty that you will get the zero result, that will be say as neutral solutions. They don't show that it is either red means it is a indicator of acidic solution, or it will not show as a blue, that it will not show as a blue, so it might be not having the any result, so that time you will say neutral solutions. So these substances are neither acidic nor basic. Okay, so what we will do that time? So we have here turmeric is another natural indicator. Okay, so for that we have one more activity. So you just pause the video and you can read that. Okay, so now these are the activities there you can use as a turmeric as a natural indicator. Take natural okay, so just make a turmeric solution here. So you can make a beautiful greeting card like that. See, turmeric solution and then soap solution. Draw anything with the turmeric solution and just put means again you can fill that drawing with the soap solution, so you will get a beautiful colors. Okay, this is just a reaction between turmeric solution and soap solution. So turmeric act as a indicator, that is natural indicator. Okay, so now here it is turning into which color? Blue color, means it has a soap solution is a basic in nature, right? So now one more is there, China rose as an indicator. Same you have to do this activity by taking collect some China rose petals and place them in a beaker, and then add some, where it is, warm water. Keep the mixture for some time till water becomes colored. Use this colored as an indicator. Add 5 drops of indicator to each of the solutions, which is given in table number 4.4 here. So initial color, what is the initial color, and then final color. So first color and the second one. So you have to do this. Okay, so what is the effect of the indicator on acidic, basic, and neutral? So acidic it will turn into red, then basic it will turn into blue, and neutral it is nothing. So China rose indicator turns acidic solution to dark pink. So according to the indicator, the changing colors will be different. Okay, that will be the not same red and blue, right? That is for the litmus one. So turns acidic solutions to dark pink, that is magenta, and basic solutions to green. Means if we are using China rose indicator, so acidic solution will give dark pink color and basic solution will give green in color. Okay, so now it is one riddle. Coffee is brown and bitter in taste. Is it an acid? Coffee is brown and bitter in taste. Okay, so what is the coffee? Either it is base or acid. So don't give the answer without any taste. You are in the dark with its taste. Yes. So according to the bitter, it might be base, but again we have to use indicator to test it, right? So the teacher is requested to dilute solution of the following chemicals. So what are these? Hydrochloric acid, that is HCl, sulfuric acid, H2SO4, nitric acid, acetic acid, sodium hydroxide, NaOH, ammonium hydrochloride, Okay, NH4Cl, calcium hydroxide, that is lime water. So we have to carry that at the so demonstrate the effect of the three indicators on each of the solutions. Record your observation in table number 4.5 here. Same, if we have the solutions, we can do this activity. So before that, are you familiar with the term acid rain? Yes, again here the acid word comes, that's why this topic is here. Have you ever heard about damaging effect of acid rain? As the same indicates, the rain containing excess of acids in is called an acid rain. So where do these acids come from, right? So the rain becomes acidic because carbon dioxide, sulfur dioxide, and nitrogen dioxide, which are released into the air as pollutants from the vehicles, dissolve or in factories, dissolve in raindrops to form carbonic acid, sulfuric acid, and nitric acid, respectively. So acid rain cause damage to the buildings, historic monuments, plants, and animals. We know that is the Taj Mahal monument, okay, which has the change in color, right? Because of this only, because the reason is acid rain. Okay, so now let's understand about neutralization. What is the neutralization? We have learned that acid turns blue with the litmus red, and bases turns red litmus blue. So let us see what happens when an acid is mixed with a base. Okay, so we are going to use an indicator. Have you not used so far? That is phenolphthalein. Okay, phenolphthalein indicator. So here one again activity is there. So to be demonstrated by the teacher in the class only. Fill one fourth of the test tube with the dilute hydrochloric acid here, acid that is HCl. Then note down its color. So note down the color of phenolphthalein solution. Also add 2 to 3 drops of indicator. Okay, adding after addition of indicator. So now shake the test tube gently. Do you observe any change in the color? Yes. After changing, look at the color. So add to the acidic solution a drop of sodium hydroxide solution by a dropper. Stir the tube gently. Is there any change in the color? Okay, continue adding sodium hydroxide, that is a base. Okay, solution drop by drop, and while stirring till the pink color just appears. So now add one more drop of dilute hydrochloric acid. What do you observe? The solution again becomes colorless. Okay, so again add one drop of sodium hydroxide solution. Is there any change in color? The solution again becomes the pink in color. So it is evident that when the solution is basic, okay, when solution is basic, phenolphthalein gives a pink color. On the other hand, when the solution is acidic, it remains colorless. Okay, means phenolphthalein gives, okay, when it is a base, it will give pink, and when it is acid, it will give colorless. Okay, so when an acidic solution is mixed with a basic solution, both the solution neutralize. Okay, both the solution neutralize the effect of each other. When an acidic solution and base solution are mixed in a suitable amounts, that should be in suitable amount. Okay, suitable amounts, both the acidic nature of the acid and basic nature of the base are destroyed. So the resulting the solution is neither acidic or nor basic. So touch the test tube immediately after neutralization. What do you observe? Okay, what do you observe in neutralization reaction? Heat is always produced. Okay, any reaction there is a either absorption of heat or releasing of the heat. So always there is production of heat. So always heat is produced or evolved means absorbed. So the evolved heat raises the temperature of the reaction mixture. In neutralization reaction, a new substance is formed. This is called salt. Okay, so salt may be acidic, basic, or neutral in nature. So thus neutralization can be defined as, so we have here definition. So the reaction between acid and base. Okay, when reaction is in with acid and base, we will get salt plus water and heat is evolved. Okay, this is a neutralization process. The reaction between an acid and base is known as neutralization, and salt and water are produced in this process with the evolution of heat. Okay, so the following reaction is an example. For example, HCl, that is hydrochloric acid, plus sodium hydroxide, that is NaOH, gives rise to sodium chloride, that is NaCl, common salt. Okay, common salt which we are using in the kitchen, gives rise to water. Okay, so Vujo added dilute sulfuric acid to lime water. What will be the next reaction? Either it is will become hot or cold. Okay, now neutralization in everyday life. What is the other examples we can relate with this? Indigestion. We already learned about the digestion in our sixth standard class. So our stomach contains hydrochloric acid. It helps us to digest food, right? Our stomach contains hydrochloric acid. It helps us to digest food, as you have learnt in chapter 2 also. Yes, in in this class also we have learnt in nutrition in animals. So but too much of acid in the stomach causes indigestion. Sometimes you feel painful this indigestion. To relieve indigestion we take an antacid. Okay, we are taking this such type of tablets. Okay, so such as milk of magnesia, which contains milk of magnesia, which contains magnesium hydroxide. It neutralizes the effect of excessive acid, means we are just balancing the acid amount. Now next one example is here, ant bite. When an ant bites, it injects the acidic liquid, that is formic acid, into the skin. The effect of the acid can be neutralized by rubbing moist baking soda. Okay, we can use this moist baking soda which are using in the baking products, right? So while preparing baking products, it also known as sodium hydrogen carbonate or calamine solution which contains zinc carbonate. Now, soil treatment, how we can use this? Excessive use of chemical fertilizers makes the soil acidic. Plants do not grow well. The soil is either too acidic or too basic. So that time, when the soil is too acidic, it is treated with the bases to make it balance by using the quick lime, that is calcium oxide, or slaked lime, that is calcium hydroxide. So these names also important. You have to make it, means you have to make a note of these names. Okay, so if the soil is basic, organic matter compost is added to it. Organic matter releases acids which neutralizes the basic nature of the soil. Now, factory waste. The waste of many factories contain acids. If they are allowed to flow into the water bodies, the acids will kill the fish and other organisms. So, the factory wastes are therefore neutralized by adding basic substances. Okay, so in this way, we are using this type of a reaction, that is a neutralization reaction, in our day to day life also. In even in the kitchen also, we are using. Okay, so here we have finished this lesson. Fourth lesson, we will see the exercise. Okay, so the first question is state differences between acids and bases. So you have to make two columns about acid and bases. First of all, the nature, the taste, that is sour, which shows, and it is shows bitter and other tastes. Okay, you have to give the examples, and the nature also you have to show, that is acid is present and here base is present, and give the examples. So in this way you can write. Now second question, ammonia is found in many household products such as window cleaners. It turns red litmus blue. So what is its nature? When red litmus turns into blue, it shows the basic nature. So ammonia has basic nature, base in nature. So name the source from which litmus solution is obtained, that is a lichen. What is the use of this solution? We are using for differentiating or identifying the solutions as acid or base. Okay, so question number 4 is the distilled water acidic, basic, or neutral? How would you verify it? By using the same way, that is a indicators. Describe the process of neutralization with the help of an example. So where neutralization means when acid plus base reacts together, form salt plus water, even the heat also produced. Okay, so that is the process of neutralization. Now mark true and false. Nitric acid turns red litmus blue. False. Nitric acid is the acidic, so it should be um, blue to red. Sodium hydroxide turns blue litmus red. True. Sodium hydroxide and hydrochloric acid neutralizes each other and form salt and water. Sodium hydroxide, hydrochloric. True. Okay. Indicator is a substance which shows different colors in acidic or basic solutions. Indicator is a substance which shows different colors in acidic and basic solutions. Yes. Tooth decay is caused by the presence of a base. Tooth decay, the cavities. Okay, cavity is present by the base. It is acidic. False. Now, okay. Dorji has a few bottles of soft drink in his restaurant, but unfortunately, these are not labeled. He has to serve the drinks on the demand of customers. One customer wants acidic drink, another wants basic, and third one wants neutral drink. How will Dorji decide which drink is to be served to whom? Okay, by checking. Okay, he can just choose check with the litmus paper. So he can use that method. Explain why an antacid tablet is taken when you suffer from acidity to neutralize the acidity. Then calamine solution is applied on the skin when ant bites. Okay, so ant bites is showing the that is a release of acids, and calamine solution is having the base. So we are just neutralizing by using these calamine solutions. Now factory waste is neutralized before disposing it into the water bodies, because we can save aquatic animals. Okay, life of aquatic animals. Then three liquids are given to you. One is hydrochloric acid, another is solution hydroxide and sodium hydroxide, and third one is sugar solution. How will you identify them? You have only turmeric indicator. Okay, so same way we are using turmeric indicator, hydrochloric, that is a acid, then this one is a base, and sugar solution we don't know. It might be in neutral neutral in nature, right? Now, blue litmus paper is dipped in a solution, it remains blue. What is the nature of the solution? That is neutral. Consider the following statements. Both acids and bases change color of all indicators. We have to see, okay, we have to check. Okay, if both acids and bases change color of all indicators, if an indicator gives a color change with an acid, it does not give a change with a base. Yes. If an indicator changes color with a base, it does not change the color with the acid. Yes. So change of color in an acid and base depends on the type of indicator. Yes. So D is also correct. Okay. Then this is also correct. This is also correct. Both are correct. All are correct. Okay. So in this way, we have finished chapter number 4. If you have any queries, you can just comment down. Okay. Thanks for watching.